Welcome to this final look at the key activities in the implementation stage. So the aim of this particular lecture is just to finalize the topic so that we're able to say that we have completed and discussed the key stages in the implementation stage. So file conversion, this is the activity, it's another key activity of course, that is undertaken at a point where user acceptance testing has been done, meaning the user has formally accepted the system as a reflection of the requirements that they specified in the beginning of the development process. And now you want to move the information from the current system onto the new system. There are many scenarios that are obtaining when it comes to file conversion. So for example, you may have a situation where the current system is a manual system and the new system that is being considered is automated. Now, again, we'll have another situation where it's an existing automated system and you want to transfer the information onto the new automated system. Again, you may have a situation where you want to implement a manual as well as an automated system, but whatever the instance, whatever the case, you still need to perform what we call file conversion. In its most basic terms, this is simply the moving of information from the current system onto the intended or the new information system. So file conversion, of course, can take place in many ways. If you are moving information from the current automated system onto the new automated system, there's a possibility of you writing some code or some algorithm that will be able to move the information or to import data from one into another. So meaning I import from the current system into the new one. But we find that in such cases where you have two automated systems, there may be instances where the information that you are transferring may not be complete, in a sense that there will be maybe new fields that have been specified in the new system that are not there in the current, or in some instances whole tables or tables which have been specified and created in the new system for which there is no equivalent in the current system. So in that instance, has also been guided in the module, we may have various file conversions or data conversions that may be carried out to achieve one purpose. So there we may have a situation where maybe the formats that are being used in the two systems are not compatible. We may need to create an API that is able to an API that is able to stand between to communicate or to effect communication between the various standards, or we may need again in instances where there are empty fields created by the conversion from one to the other or the transfer of data from one system into the other one, we may need to develop or devise other means in which we are going to fill up those empty spaces or those empty tables for which information does not exist. Or we may have seen, especially periodically and especially during industrial break times and so on, we will see or notice some adverts in papers asking for data entry clerks for organizations. Usually you find that such jobs are temporary, maybe 3 months, 6 months, and the sole purpose is just to sit before a new system and enter information manually. So from box files, you key into the new system, end of the process, information has been transferred from the current system into the new system. So whichever means or whatever strategy that you devise in order for you to move information from one into the other one, it's up to the context, it's up to the agreement between the user and the development team, it's up to the capacity of the development team and other factors. But whichever the case, there needs to be a mechanism or strategy that is developed to move the information from the current into the new system. Now, to make it more practical as to why we need this activity and why I'm calling it a key activity as part of system implementation, let's think about your device, your phone, or your tablet, or your laptop. You have an existing device, and as you reflect upon the activities in which you undertake with the same device, you will discover that most times you rely upon the information that the device has in order for it to perform various activities. So if, for example, your device is, maybe if it's a phone, it has a cracked screen, or the touchpad is not as sensitive as it used to be, and then someone comes and says, I'm going to give you a new phone. The new phone will, of course, will be a welcome addition to your toolkit of devices that you have, but you will not necessarily be able to make full use of the new device until you move the information from the old phone onto the new phone, so that you are able to have the same services, including other value addition activities, being possible because of the information that the device contains. So no matter how upscale the phone is, no matter how fast and so on, most times, or the usefulness to which you can employ it depends on the information that that particular device contains. This is actually even more the case when it comes to information systems. So file or data conversion is simply moving the information from the current system onto the new system that is going to be implemented to take over from the old system. Whether it's going to be manual data entry, whether you're going to use a code to transfer, whether you're going, if a system has the capacity to import information or to export from the current one into the new one, that is up to the circumstances, the team, the agreements, and so on and so forth. But what is important is that the information needs to be moved. And once this information is moved onto the new information system, it is important that you check or you put in place controls to gauge whether or not correct data has been entered into the system. Why is this important? This looks at the integrity of the information which has been entered, and usually this information is high in volume, meaning it's a lot of information. So now if you import a lot of information into the new system and then that information is not correct, the years are wrong, the names and so on, fields are placed anyhow, then that information essentially becomes useless. Integrity, when it comes to data controls, looks at the correctness of the information that has been entered or that is being used in the information system. And one of the ethical considerations for an information system practitioner is to ensure the integrity of data which has been put into an information system. So of course we have various courses which discuss data checks or data controls. Even in the module we have a number. They have been put there just for the purpose of your revision, but it's important that you put this in place as you are moving information from one into the other. For example, one of the manual ways of ensuring correctness of data is simply proofing the information. Proofing in that you have a set, let's say you have had someone on a data control, data entry basis for 3 months. Once they finish their input, let's say you have thousands of box files. Once that input has been done, one of the manual ways of validating whether that data is correct is to simply give it to a second group who will not be necessarily keying in the information, but they'll be going through line by line to check whether the information is correct. Or if it's a database of maybe students' information, you can simply run a duplication check on the entries to ensure that two records have not been entered, two same records have not been entered by error. So it is our responsibility again in this case as a development team to ensure that what data has been input into the new information system that is about to be implemented in the user environment is correct. And that is data and file conversion. Bearing in mind that errors are normal, they are part of the process, what is important is we put in place controls and procedures that would detect those errors and correct them before the information system goes live. So at this stage, we have tested our information system, the user has accepted it, we have converted the information from the current into the new one, meaning the data has been entered, Now we'll move on to the actual changeover or installation of the information system. And it's again an activity where we involve users because now we are formally installing the system or giving it to the owners. So now when it comes to changeover, there are, ladies and gentlemen, four distinct types of changeovers or installations. Simple terms, this is where now you are installing the information system into the user environment. So we have the direct changeover, also called the cutover. We have parallel, we have pilot, and we have the phased. So we're going to look at each of these handovers or changeovers, highlighting the advantages and disadvantages. Direct changeover, this is a changeover where the old system is retired and then the new system is installed. And we call it direct because, or direct cutover, because the new system, the minute it comes into play, then the old system is no longer in use. And usually, this type of changeover is normally done when there's a break in the operation of the organization. So, for example, if it's a learning institution during school break or term break, when there's no student activity in the system, then you can remove the old system and install the new system. When the students report in the next term or the next semester, they find a new system in place. That's direct, meaning you've stopped using the old system and the new system is in place. Then we also have, for let's say other organizations, such as banks, for example, we have the industrial break period. When the company closes for stock taking, they close for industrial break. The new system is installed. When the people report back to the organization, they find the new system is running. This type of changeover is good because in terms of cost, you do not incur a lot of cost in that you won't have two systems running at the same time. You remove the old system, new system comes in. In terms of the implementation team or installation team, they'll come, they install, they go. Costs are cut. Now, that is the biggest advantage. Now, on the other part, it has a big disadvantage in the sense that in the event that the system fails, there is no fallback for the organization because that is the only system that is running. So if it fails, develops errors or any other issues, it means everything will ground to a halt. That is the direct changeover. Then we also have what we call the parallel changeover. Parallel, this is where now you have the new system and the current system or the old system running together. Ideally, this is done to ensure that the new system is able to perform as specified, it is tested, and then once it is gauged as fully operational, then slowly the new old system is retired and the new system remains running. Now, additionally, it is also good in the sense that it allows us to compare output between the two systems. So if we said when the new system comes, it will be able to tackle 20 transactions in a second, for the sake of argument, while the current system cannot even process a single transaction in a second, that will allow us to compare the two systems. Then we're able to see that, okay, the new system is actually faster than the old system. Now, in terms of advantages, parallel changeover is extremely reliable because not only are you able to have a point of comparison, it means that in the event that the new system malfunctions, you have a old system to fall back on. So it allows the transition from the current system into the new system to move in a highly supported manner, and it ensures that it is seamless because the disturbance is minimal. They can still see the old system in case of any errors, in case of any questions. They're able to actually perfect their skills before you completely win off the current system. Now, in terms of cost, of course, it's highly reliable in terms of advantages, but in terms of disadvantages, it is costly because you are running two systems at the same time, meaning that stationary again between the two systems, including manpower itself and other administrative overheads. Then some texts will also say that in terms of acceptance of the new system, it is a bit compromised in the sense that because the users are able to see the old system, it is difficult for them to see the full need of the new system because they can still see the old system and it's functioning according to how they are used to. So you find that in extreme cases, users may actually sabotage the new system so that they remain with what they know and what they are familiar with. Though that is in extreme cases. So we are saying disadvantages is costly. Then in some instances where the systems are completely different, a point of comparison is not always possible. But the advantage is it is highly reliable and it also allows a smooth transition from the old system to the current system, to the new system actually. Then the third one is what we call the pilot changeover. Now, this is where both systems are in operation, but key areas are selected to run the new system and they are evaluated on how the new system performs. So, for example, it's a bank or okay, yeah, with a bank with branches across the country, and then you say Luansha branch, we are installing the new system, but the other branches remain using the old system, and then Luansha branch is used as a test site where we're able to gauge and evaluate and assess whether the system is running as expected, it's yielding the projected advantages, any teething issues, and so on. So that once the pilot succeeds, then we roll out to the other branches for the bank. So that after a certain period, the new system is installed across the organization or across the branches. That is pilot. So you pick a site where you run that system, and then based on what will transpire on that pilot on that site, isolated from the other places, so that in case there's a system failure, you're able to roll back to the old system, and the other branches are not affected. That is a pilot. So in terms of cost as well as risk, it's medium in the sense that you are not doing a pilot for all the branches, just a selected. So the cost at least is much more manageable compared to a full rollout across the branches. And in the event that there's a system failure, only a certain component or part of the organization, specifically the branch, is affected. And most instances, it's possible to roll back from other branches which have not been affected by the pilot. So whether or not you proceed to install across the organization depends on the success of the pilot. So if the pilot fails in Luansha, then it means the other branches will remain undisturbed and will roll back in Luansha to the previous system. Now there, we will have a disadvantage in the sense that if Luansha conditions were not favorable for the pilot, we may say will not roll out. But if it had gone in other branches, it would have been successful. But because you're basing on the success or otherwise of the pilot, you find that a very good system may not end up not being implemented in other branches or across the organization. That is the pilot. Then last but not least, we have what we call the phased changeover. This is where the system, especially very big systems, is not implemented in full, it is implemented in parts or phases. So if I have a student information system which has a lot of modules, let's say there's a hostels module, there's a transport module, there's an accounting module, there's a human resource module. If you take maybe, let's say, leave days for employees and so on and so forth, there's a medical module and so on. I may say instead of installing the full SIS activity C, I'm just going to install maybe the fleet management or transport module. So that will affect, of course, for TVTC, the fleet manager is human resource. So it will affect human resource. It will affect the drivers because we'll need to know which vehicle has been assigned to who, when, where, and so on and so forth. So now that installation will just be for that particular module. And then the same conditions as the pilot apply in the sense that if the transport module runs successfully over a period of time, then we'll be able to say, okay, now let's go on to the hostels module. Let's install that one. And again, you assess what is the impact, how is it integrating, and so on and so forth. What are the benefits? When that one passes master, then we'll say next one, just like that. Until after a period of time, the full system is installed, as opposed to installing a big system that is affecting key areas of the organization and everything is impacted at once. Phase ensures that the change is gradual, allowing things like user acceptance, familiarity, also gauging the effectiveness. So in the event that the transport module fails, then we roll back to what we had before. And only transport is impacted, the other parts of the organization remain operational. So just like the pilot, phase also means that the installation of the system will take a period of time. It is not instantaneous because you'll be implementing module by module. Of course, there are instances where maybe the first two phases are successful, then we'll say instead of rolling out another phase, you just say, let's roll out everything else. Since it has been proven that it is effective, it is steady, and so on and so forth. So in this particular changeover, risk is moderate, same as the cost. You only affect in the place where the phase is being implemented or that part of the system is being implemented. The rest remain untouched. Then you'll be able to move forward based on the feedback from that phase that has been implemented as part of system changeover or implementation. So collectively, what we have discussed, we are saying when it comes to direct changeover, the risk is high, but the cost is low. Pilot and phased, cost and risk moderate. Parallel, cost is high, but the risk is very low. So which one you use depends on your circumstances and other key factors that we have been discussing throughout the implementation phase. So the type of business, for example, the duration, meaning when the project should run, and so on. So you find that, for example, some projects may benefit from phased approach, but because it has to be implemented in a particular period of time, it may not be feasible. So we'll say we will not use phase because we don't have the time to run it over a long period of time. So at the end of maybe 3 months, 6 months, sometimes even a year, depending on the size of the project, the whole system is installed. Okay. Then, ladies and gentlemen, we have the post-implementation evaluation. Now, this is where, after the system has been in operation for a period of time, you need to evaluate. When you are conducting analysis and investigation, you highlighted problems, then you said this system, once it is implemented, is going to mitigate those problems. So post-implementation, of course, there's a long checklist usually on what you're looking for, which we'll discuss shortly. Wants to see overall, is the system performing as you envisioned when you are creating it or sanctioning its creation? And that is a key activity. And once you assess the implementation, then you are also going to submit a final report as a development team to management. So now, when it comes to the evaluation, you need to look at the accuracy of the system. Based on the requirements, based on what the user expects, how accurate is the system? How complete is it? Is it as fast as you said it's supposed to be? When you said currently we have a system that takes 30 minutes to produce a report, then you said the new one will produce 100 reports for the sake of argument per 30 minutes. Post implementation wants to verify whether the system is actually able to produce that volume of reports. How happy are the users with the system? especially based on what they identified as the weaknesses in the current system. What has the new system delivered? How reliable is the system and how easy is it to maintain? Remember, under training, we talked about the technical people who have been trained. You find out from them how easy is it to back up, how easy is it to create accounts, how is it to reset passwords, and other key issues. You ask users how easy is it for them to recover from an error in the system? How easy is it for them to go back to a previous, if at all? In terms of content awareness, how is the system responding to that particular concern from the users? Then you also look at how adequate are the system controls. Are you able, for example, to enter characters in a field that you have specified as strictly for integers? In short, those input controls that you put in place as part of your user interface design, are they being actualized in the current system? How good is the security? How are the access privileges being implemented? That is part of post-implementation evaluation. How efficient is the hardware? How is it performing? Does it freeze? If it does, how many? Is that more or less than what was happening in the previous system? How good is the database? How easy is it to query? Can you create ad hoc reports from it and is able to respond accordingly? How is the maintenance team performing? Those within that you train to support the users and also yourselves in terms of response time when the user has a particular query or challenge. How good is the documentation? How good are the manuals? How good are the reference manuals? How good are the documentation behind the coding, the narrations? How easy is it to correct? How is or how was the training, especially when now they are using the system? Are they able to use it effectively? Have they been trained to the level where they're able to work with the system without need for assistance? How accurate are the benefits, especially that you said will be actualized when the system is implemented? Especially if you did a very good feasibility report there, you need to look at. You said you spend this much, but then you said in terms of new transactions and so on, the benefits will be 500,000 quarter. Is that the case? That is part of evaluation. Now, as you are performing this post-implementation evaluation, you will use the same fact-finding techniques that we discussed in analysis stage. So, are you going to interview users? Are you going to distribute a questionnaire? Are you going to observe them as they work? But the idea is you go to the, no wonder we talked about user involvement, you go back to the user to find out how is the system performing. Now, when you are looking at post-implementation evaluation, in an ideal situation, it should be done by those people who were not part of the development process so that it is as objective as possible. So if you have delivered a bespoke system, it's been implemented, people are using it, there is nothing wrong with the IT team within the organization to conduct a post-evaluation so that they ask their users, how are you finding the system, and so on and so forth. Then, other instances, you may find that you may actually have external organization or institution coming to perform the post-implementation evaluation. This can be an IT vendor, it can be a consultant hired specifically just for that activity. Again, which one you use is up to the organization, the developers, and other key factors that we have been discussing. Now, when you have a evaluation, post-evaluation, the idea is it should not take place so far into the future or so far after implementation that the users have been forgotten how the old system was and how the new one compares. So ideally, you can have maybe maximum should not be more than 6 months after. Because again, if it's too early, you find people are still getting to grips with the new system. They may say things are bad, not because they are bad, but because they haven't yet gotten used fully to the new information system and they still have the old system in mind. So you give it a bit of time so that even the benefits are able to be actualized. The users have gotten to grips in terms of how to use the system. And then you ask them now, how is the system running based on what you have as your check against the effectiveness of the information system. So there's a question in the notes. This one we can discuss when we meet face to face. But let's move on now to the final report to management. What are the contents? So when you are submitting to management, this is the last activity apart from maintenance, which will follow as the next stage. You need to ensure that that report, ladies and gentlemen, contains all the system documentation, all the manuals, all the codes, all system documentation should be part of the final report, ideally as an appendix. Then you also indicate what are the key things that need to be looked at in the event that you want to enhance the system. So this system does this, but for the future, it's possible it can do additional activities such as 1, 2, 3, 4. Based on the requirements that were given, type of users that are using, the technology under which this thing was developed. It's possible the technical team you can indicate to say this system can also be enhanced in such and such a manner. You summarize cost benefits of the information system as well as the activities which were conducted, schedule which one started first, next, and so on and so forth, which one ran in parallel. It's important so that the key activities are clearly stipulated. Then you should also have a component to compare, ladies and gentlemen, between how much you spent, actual as it is known, and the estimated. You said we will spend 100,000, but in actual fact we spent 150,000. And break down exactly what you spent it on and what maybe to some extent you can try to indicate what brought the variance between what you estimated and what you actually spent. Then you also attach the post-implementation evaluation, the findings, if it has already been done. Though you will have instances where the final report is being submitted without the post-evaluation having been conducted. In that case, you will leave it out. But it makes the report more meaningful when you also have the evaluation results reflecting, so that it answers to what was predicted or envisioned in the beginning. Then, when that is done, ladies and gentlemen, you submit the final report to management. You have finished the implementation stage. So, system implementation is a key activity in system development because that is where the user is heavily involved. So, we perform a number of activities there. One of the key activities is documentation for the entire information system in the shape of manuals, system requirements, which need to also be clearly documented, final report. User acceptance testing is also conducted. Training program is done for the 3 types of users. Then you also perform data conversion, install the system, conduct a post-implementation evaluation to assess the effectiveness of the information system, and submit a final report to management. We should also clearly indicate or stipulate the project costs. And the submission of the final report indicates the end of the implementation stage. And that, ladies and gentlemen, is implementation stage.